Okay, let's say today you are doing work energy and power. So the statement says the 20 kg block is released from rest from the top of a ramp at point A at a construction site as shown in the diagram below. The ramp is inclined at an angle of 30 degrees to the horizontal, and its top is at a height of 5 meters above the ground. So the first question says state the principle of conservation of mechanical energy. So from the exam guideline or anywhere we know that we can find the definition, it states that the total mechanical energy of an isolated system remains constant, or it is conserved. So we can say the total mechanical energy in an isolated system remains constant. So this is how we state the principle of conservation of mechanical energy in weights. So now the second question says if, or let's say the kinetic energy, the kinetic frictional force between the 20 kg block and the surface of a ramp is 30 Newton. Use energy principle to calculate the work done by the kinetic frictional force on the block. So 6.2.1, we should use the energy principles to calculate the work done by the frictional force. So let's say we know that the work done by any force is equal to the force that is applying on the block or on the object multiplied by change in x, or the displacement that the block is traveling, cos angle. So the angle is the direction of an object. So since now we're talking about the work done by frictional force, so we can say this is the work done by frictional force. We just put the small f for frictional force. So now what is this force? Is the force that is applying on the object. So this is the frictional force for now. So what is frictional force? We are given frictional force as 30 Newton. So we have 30 Newton for frictional force. Now what is the change in x? The change in x is the distance from A to B. So since we don't have the distance from A to B, but we know that this is the perpendicular height, so this is the right angle triangle now. So how can we get the hypotenuse side from the right angle triangle? So we can use the trig ratios. So let's say we use sine this angle is opposite all over hypotenuse. So sine theta is equal to opposite, let's say opposite all over hypotenuse. So sine the given angle, which is 30 degrees. So we have 30 degrees is equal to the opposite side. The opposite side is the perpendicular height, which is 5 meters. So we have 5 all over. The hypotenuse side is the distance between A and B. So we can call it change in x. So now we know that the sine theta from the triangle, or from the right angle triangle, is equal to 1 all over 2. So we can say just sine theta is equal to 1 all over 2, 5 over change in x. So now let's say we cross multiply this times this times this. So the change in x is change in x times 1. It's just change in x equal to 2 times 5, which is 10 meters. So now our change in x, or the distance between A and B, is equal to 10 meters. So we just go to the formula and write 10 for change in x. So cos, what is theta? Theta, like I said, is the direction of the force. So since we take the original direction of an object as 0, so any force that is opposing the motion of the object, it takes the 180 degrees. So since frictional force is the force that is opposing the motion of an object, so this one, it will take 180, or it always take 180, because frictional force is always opposing the motion, so it always takes 180 degrees. So we know that cos 180 degrees is -1. So let's say 30 times 10 is just 300, times 180, cos 180 is just -1. So now 200 times -1 is just -300 joule. This is the unit for energy, or the work. So it's joules. So this is the work done by the kinetic frictional force on the block. Now let's move to the following question. Let's say now the question says calculate, or use the energy principle to calculate the speed of the block at the point B at the bottom of the ramp. So which one are we going to use? Because we have multiple energy principles. So let's say now we say work net, let's say this is 6.2.2. so we're going to use work net from the exam guideline, or from the formula sheet. Work net is equal to the change in kinetic energy. So what is work net? Work net is the total work done on an object, or acting on an object. So since from this diagram, let's say we draw a free body diagram on this. So the free body diagram will be like this. We have normal force, we have friction opposing. Remember, the block is going sliding down, so this is the frictional force opposing the motion of an object. This is the perpendicular weight. This is the weight perpendicular. This is always going with normal force. And then we have the weight parallel here, always going down. So now, since even if we are calculating the net force, we always use the horizontal forces. So here we're going to use the horizontal forces to calculate the net work done on an object. So now work net is equals to the work done by the weight parallel plus the work done by the frictional force. So we only have two forces acting on that block, or the horizontal forces. So now what is the work done by weight parallel? So we know that weight is equal to mg sine theta. This is the force. Now the change in x is from the formula. Remember, the formula is work is equal to force change in x cos theta. So the mg sine theta is this force. Now the change in x is that change in x, then cos theta, plus the work done by frictional force. We already have the answer. We calculated the work done by the frictional force as negative 300 joules. So we're just going to say it's negative 300, just like that. So now, what is m? M is the mass of an object, which is 20. G is 9.8 due to gravity. Sine angle, or the given angle, as 30 degrees. Now, let's see, we take this. Then the change in x, we calculated the change in x as 10 meters. Remember that? So now we're going to put 10 here. Then cos. Let's look at the free body diagram now. The block is sliding down, and the way the parallel is going where is going in the direction of the block. So it takes it takes this should be cos 0. It takes the original direction, or the direction of the block. So it's 0, then minus 300. Oh, it's 300. Then we move from here. Now it's 20 times 9.8 times sine 30. We know that sine 30 is 1 over 2. So the answer is going to be the whole answer here, the whole answer from here, it will be 980, then minus the 300 for frictional force. So now, what is 980 minus 200? It's just 68 joule. So this is the work, the net work done on an object. So now, how are we going to calculate? How are we going to calculate the velocity? How are we going to calculate the velocity of the block? Okay. So we are required to calculate the velocity of the block at point B. So now, work net is equal to the change in kinetic energy. So what is the change in kinetic energy? Work net is equal to 1/2 mv squared final minus 1/2 mv squared initial. So from here, we know that the mass is the same mass of an object, only the velocities are different. So we can just say 1/2 mass, then vf squared minus v initial squared, just like that. So now, what is the work net? The work net, we calculated work net as 680 joule. So let's say now this is 680 joule is equal to 1/2. What is the mass of an object? The mass of an object is 20 kg. So we put 20. So the final velocity of the block at point B, this is what we are looking for, minus the initial velocity of block B is 0 at the top. Remember, it was released from rest. So this is 0. So from here is 680, just like that. is equal to 20 divided by 2, or 20 multiplied by 1/2 is just 10. 10 times v, so it's just vf squared. So from here, just divide by 10, so vf squared is equal to 680 divided by 10, just 68.